Hi everyone, welcome to this tutorial on SciComm, a flexible, web-based platform for collaborative research, data analysis, and machine learning. In this video, we will use SciComm's machine learning feature to demonstrate a multivariable regression workflow using a decision tree regressor. Let's start with the core idea behind our approach. Multivariable regression is a statistical modeling technique used to understand the relationship between one dependent variable and two or more independent variables. The dependent variable is also called the response or target, and the independent variables are often referred to as predictors, covariates, or input features. Now that we've introduced multivariable regression, let's take a look at a real-world example. In this case, we'll be working with data from tensor tests, a common method used to evaluate the mechanical properties of materials. Our goal is to predict yield strength, a key indicator of how much stress a material can withstand before it begins to deform permanently. To do this, we will use several input features such as test temperature, reduction of area, and various elements in the material's chemical composition. This example gives us a practical way to explore how multivariable regression works in the context of real experimental data. The dataset we're using includes 21 input features derived from stainless steel tensor test experiments. The output we want to predict is yield stress, measured in megapascal. This high-dimensional input space makes it a great candidate for machine learning models that can handle nonlinear relationships. Now, let's talk about the decision tree machine learning model we're using in this task. Decision tree is a non-parametric supervised machine learning model used to predict continuous target values. The model works by recursively splitting the data based on feature thresholds that reduce prediction error, usually using mean-squared error as the loss function. The diagram on the right side of the slide is a simple example of how decision tree regressor makes predictions. At the top, the root node, the model checks whether the test temperature is greater or equal to 400 degrees Celsius. If the answer is yes, it directly predicts a yield strength of 675 megapascal. If the answer is no, it looks at another feature, the reduction area. If that is greater than 65%, the prediction is 708 megapascal. Otherwise, it's 712 megapascal. This tree-based logic continues for larger models, splitting the data into smaller regions where predictions are based on local averages. This slide shows the overall workflow for training and evaluating a machine learning model using our tensor test dataset. The dataset is split into two parts, 80% for training the model and 20% for testing, which allows us to evaluate how well the model generalizes to unseen data. After training, the model makes predictions on the test set. We compare those predictions to the actual values. Finally, we evaluate the model's performance using R-squared score, also known as coefficient of determination. The formula shown here calculates R-squared, where values closer to 1 indicate better prediction accuracy. It essentially measures how much of a variation in the true data is captured by the model. This is our SciComm machine learning interface. You can write down your project name here, and this is our description of our project. It's a demonstration of using decision tree regression to perform multivariable regression with the SciComm web application. We use a tensor test dataset with multiple input features to predict a continuous target variable. Yield stress, the demo works through uploading data, selecting the target label, configuring the method, and running the model to evaluate its performance. On the data type section, there are 4 types of data we can choose: tabular, image, text, and signal. Here we choose tabular because our data is saved in a CSV file. And then we click Upload CSV and click this button to upload. Here I choose our tensor test yield stress data and click open. And you can see the data is automatically uploaded to our database. And here is the overview of our data. So you can see on the top is all of the columns names. And the last column is our target, yield stress. This is the table section, and we can also choose the data section to have an overview of the data. So here, the first part is no instances. Scikon interface automatically calculate the null interface of your data. It can help you to understand if your data has some invalid values. And here also tells you the data type of each column, and also gives a summary of unique values of your data. Now, we can choose the machine learning algorithm we want to use. Click here. We have classifier on top of the list, and on bottom of the list, we have regressor. Since this is a multivariable regression issue, we're going to choose our decision tree regression. And then we can choose the evaluation metrics after the prediction. Here we use the R-square, as we discussed previously. And then we click perform. This is our final evaluation result. The R-square score is 0.95, which is quite high. And it means our model was able to have a very accurate prediction. Since our data has 21 input features, this 2D plot is not applicable to our data, but it is a great visualization tool for one-dimensional input and one-dimensional output. If we want to see more detailed result, we can go to the table, and then on the right side, we have y-predict column. This is the actual prediction from the model, and we have the y-test column, which is the actual values from our dataset. This has been our implementation of multivariable regression using decision tree regressor in Scikon. Thanks for watching.